We want to continue to practice our corresponding parts of congruent triangles, or CPCTC proofs. So we're going to start with this one. C is the midpoint of AD. So I'm going to write this in two pieces, actually, so that you can see it. C is the midpoint of AD. So let's talk about that. I'm going to write this in a few more steps than maybe you might write it. You could write this given all in one statement, but I'm going to show you how I like to write it. So C is the midpoint of AD. So C is in the middle of AD. What that tells me is that AC is congruent to CD. So AC is congruent to CD. And that is because it's the definition of midpoint. That's what midpoint means. Okay, then that wasn't all of my givens, so now I'm going to go back and get the rest of it. C is the midpoint of EB. Again, that was given. I just split my given into two pieces. You can do that. So C is the midpoint of EB means that BC is congruent to CE. And again, definition of midpoint. Like I said, you could have written 1 and 3 in one step and 2 and 4 all in one step. That's fine. So we need more information. We have two pieces. I have a side and I have another pair of sides. I need something else. So I go back up to my picture and I look for what else I know. Oh, look, I know that these two angles are vertical angles. So I know that angle ACB is congruent to angle DCE. And that's because vertical angles are congruent. So I know those are congruent. Now I've got my three pieces. Let me double check and make sure they all work. I have a side, I have a side, and I have an angle. The angle is in the middle where it's supposed to be. And so I can say that those two triangles, triangle ACB, is congruent to triangle DCE because of side, angle, side. So now that I proved those two triangles are congruent, now I wanted to prove, in the whole first place, I wanted to prove that A is congruent to D. Well, now that those triangles are the same size, I know all of their pieces are the same size. And so I can say that angle A is congruent to angle D because corresponding parts of congruent triangles are congruent. I just said the triangles were congruent in step 6. A and D are corresponding parts. They're the matching pieces of their corresponding triangle. That those two are congruent because the triangles are congruent. Okay, so with this one, here's what you want to watch for. We've got TS is congruent to TR. So we have TS is congruent to TR, and we have SPR is congruent to, we've got SPR is congruent to RQS. So let's look at this. So TS is congruent to TR, and angle SPR is congruent to angle RQS. That's all given. Okay, so here's those two angles. So what we want to do when we look at these is, let's start here. Here's my goal, right? Let me show you where my goal is. I want to prove that PR is congruent to QS. But we're going to have to break this into pieces. Here's what I know. I know that this, I know I've got enough of that triangle and that triangle. So let's start with these two pieces and see what we've got going on. Sometimes you just have to try something and be willing to erase. Well, what I know is I know that PTS is congruent to angle QTR. And I know that because vertical angles are always congruent. So what I can say is that, I can say that triangle PTS is congruent to triangle QTR. I have three pieces, right? I have a side, I have an angle, and I have an angle. So if you look, what I've got an angle, and I've got an angle, and I have a side, okay? And the side is not in between. It is touching one angle but not the other. So those triangles are congruent by angle, angle, side. Now what I'm trying to prove is that PR is congruent. So we're dealing with our yellow triangles right now. Okay, so here, this one's a little bit tricky. So here's where we go. We start with our yellow triangles. Well, I notice, if you'll pay attention, look what you see. You see that PT and TR make up PR, and QT and TS make up QS. So remember that. We're going to go there in just a second. But first, we start with our yellow triangles. We said that our yellow triangles are congruent. So what I can say is that PT is congruent to TR. Okay, that's because corresponding parts of congruent triangles are congruent. And so here's what I know. Here's what I just said. PT is congruent to, it shouldn't be TR, I'm sorry. PT is congruent to QT. That's because of corresponding parts. So I have these two pieces right here. So if I go into my next step, so remember where we're trying to get PR. PR is the whole side of the triangle. So the whole side of the triangle, then we're going to go here and we would say PT plus TR is equal to QT plus TS. So we can say that because of the segment addition postulate. Okay, that says that I can set those equal. And notice that they're equal to each other. If PT is equal to QT and TS is equal to TR, then when I add those two pieces together, they're going to be equal to each other. So then we need to get PT plus TR. Actually, here's what we need to do. I'm sorry. We'll do this, but we're going to get there. Okay. I missed this. PT plus TR is equal to PR. That's the segment addition postulate. And QT plus TS is equal to QS. So then what we would do is if QT is equal to, so notice here, QT is equal to PT, right? QT is equal to PT. So now I've got QT is equal to PT, and TS is equal to TR. Then what that tells me is that PR is equal to QS, which is what I was trying to get to. Okay, so substitution. Okay, so I could set those equal to each other, and then I could subtract and get substitution to get PR is equal to QS. You won't ever be asked to prove anything that difficult on your own, but that is something that you could use that pulls everything together that we've been talking about this unit. BD is perpendicular to BC. You know that right angles are going to come out of that. BD is perpendicular to BC. BD is perpendicular to AD. And AB is congruent to CD. So that is all given. So we make sure everything is marked up. So we have 1. So BD is perpendicular to BC. So if BD is perpendicular to BC And if BD is perpendicular to AD, then that means that angle CBD and angle ADB are right angles. That is always the next part that comes after saying something is perpendicular. So that's step 2, excuse me. That's because it's the definition of perpendicular, lines that intersect at right angles. So we have to say that they are right angles. So their definition of right angles, or excuse me, definition of perpendicular lines. Okay, so let's get a plan together of where we're going. Remember, we have to prove the triangles are congruent. Notice that your part, and this is where it kind of helps you to know where you're going so you can decide, am I going to go side angle side or am I going to go HL? Okay, so here's what I've got. Notice that you have the hypotenuse. Since you have the hypotenuse, let's go for HL. Well, in order to use HL, these have to be right triangles. So you would say triangle CBD and triangle ADB are right triangles. And that's because a right triangle is a triangle that has a right angle. Since those are right angles, these are right triangles. So that's the definition of right triangle. Now that they're right triangles, I'm allowed to use hypotenuse leg. So I have the hypotenuse, but I need the leg. Well, if you look, BD is shared by both triangles. So BD is congruent to BD. That's the reflexive property. Okay, so now I have the two pieces that I need. I have the hypotenuse and I have the leg. It's SSA, but we're not going to use SSA because this is a right triangle. So now I can say triangle CBD is congruent to triangle ADB, because of HL. I have a right triangle, which means I have a hypotenuse, which means I can use HL. So now I know that those two triangles are the same size. So the question is then, what it's asking for is that DAB, so this angle right here, DAB, is congruent to BCD. Well, I have said that the triangles are congruent, which means that all of the pieces of the triangle are congruent now. So I can say that DAB is congruent to BCD because corresponding parts, those are corresponding parts, of congruent triangles, I just said they were congruent, are congruent. Okay. So ST is parallel to RQ. You know that corresponding or alternate interior or something like that is going to come about probably. SR is congruent to RP. And angle SRT is congruent to angle RPQ. So I have that SR is congruent to RP. I have that SRT is congruent to RPQ. And I have that ST is parallel to RQ. That's all because it's given. Now, remember that I have a side congruent to a side. I have an angle congruent to an angle, so I need something else. I either need another side or I need another angle. There's no reflexive property, so there's no way for me to get another side. So that means that I need to get another angle. Well, that's what that ST is parallel to RQ is going to be beneficial for. So if I look at that, then I look at my transversal right here. Let me draw this in. Let's use this one as our transversal. These as our parallel lines. It's not the only way, but that's the easiest way. Okay, so here's what you want to see is this right here. S is congruent to QRP. Okay, and the reason that we can say that is we can say that angle TSR, I'm going to name them both in their full names, angle TSR is congruent to angle QRP because if lines are parallel, then corresponding angles are congruent. Most of the time we use alternate interior, but every once in a while we'll have a situation where we can use corresponding. So we've got our corresponding angles are congruent. So now if you look, I've got an angle and a side and an angle because I have my three pieces, right? So I had two angles and a side. So the question is it angle, side, angle? Or is it angle, angle, side? So now I can say that triangle SRT is congruent to triangle RPQ because of angle, side, angle. The side is in between the two angles. Now that my triangles are the same size, I can say that ST must be the same length as RQ. Because corresponding parts, those two sides, of congruent triangles, I just said they were congruent, are congruent. Okay? Always start with your given. MQ is congruent to NT. If it isn't marked, mark it. I'm going to make it a little bit darker. And MQ is parallel to MT. We know that that's going to give us something about our angles. So let's look and see. So MQ is parallel to NT. So I want to use that right there. So I'm going to say, okay, well, if MQ is parallel to MT, then angle QMT is congruent to angle NTM, because if lines are parallel, alternate interior angles are congruent. Remember, we're always going with, okay, what do we have, what do we know, and where does that take us? And so this piece right here takes me here. I already had a congruent side. Now I have a congruent angle. I need something else. I don't have anything else in my given. I used that, and I look and see if I've got anything else. Well, I notice these two triangles are back to back. That means MT is congruent to MT. That's the reflexive property. So then now I've got three pieces, right? I've got two sides and an angle, and I look just to double check. I've got my side, my angle, and my side. My angle is in the middle where it's supposed to be, so I can keep going. I can say then that triangle MNT is congruent to triangle TQM because of side, angle, side. Now that I know my two triangles are congruent, I can talk about all the pieces, and that means that M is congruent to QT. That's the piece I'm asking about. I could talk about any of the other three pieces, but I'm actually asking you to prove that MN is congruent to TQ, and that's because corresponding parts of congruent triangles are congruent. Now, y'all, here's the beauty. Let me show you this because we don't have one that's going to do this, but I could, at this point, I could ask you to prove that MN is parallel to QT. It isn't, right? And we don't know that at this point, but let me just kind of show you how this would work. For MN to be parallel to QT, you would need to know that this angle NMT is congruent to this angle QTM. Well, if alternate interior angles are congruent, those are, we know they're congruent, but we know those two blue dotted angles are congruent because the corresponding parts of congruent triangles. We know that those two triangles are alternate interior angles. And if the alternate interior angles are congruent, then the lines are parallel. So I can use this to get all the way into something like that. Just a side note. All right, last one. YX is congruent to WX. And ZX bisects angle YXW. That's going to give us congruent angles. We know that bisecting angles gives us angles. So that's given. So I have a side congruent to a side. I have that side congruent to a side. It says that ZX, this one right here, that segment right there, bisects this angle. So, or no, not that angle, this one down here at the bottom. So this one bisects this one. And I want to prove that YZ is congruent to WZ. So I know that this angle is congruent to this angle. So I can say that angle YZX is congruent to angle WZX. And that's the definition of angle bisector. Nope, I messed it up. I said it right the first time. I should have left it. I'm sorry. Mark that out if you wrote that statement already. It says YXW. Here's YXW, that angle right here. So XZ cuts that. So angle YXO, or YXZ if you prefer, is congruent to angle WXZ. Okay, so here's what I'm trying to prove. I want to prove that YZ is congruent to WZ. But if you look at the pieces that we have so far, we don't have enough information about any of the triangles that are tied to that. Actually, we can. Sometimes you have to go through other triangles to do it. There's another longer proof that I was anticipating that this one doesn't actually need. So we know that this angle is congruent to this angle. The other thing that we know is that XZ is congruent to XZ. And that's because of the reflexive property. I was thinking too hard about this. So now we have XZ is congruent to XZ. And so now we can look at these two triangles. We don't even have to look at the little triangles anymore. So I know that if I look at that size triangle, I have that these two triangles are congruent. So triangle YXZ is congruent to triangle WXZ. And that is true because of side angle side. And then I'm asking you to prove that YZ is congruent to WZ. And so I can do that because corresponding parts of congruent triangles are congruent. There's another version of this where you have to prove some of the little pieces. And so you have to work your way and you actually have to prove the triangles. Several of the different little triangles are congruent to get to the bigger triangles. So that's what I was anticipating. And so it wasn't as hard as I expected it to be. So remember that you're going to look for the pieces that you have. You're going to mark those up. And then you're going to look for pieces that you need. You're going to prove your triangles are congruent, and then you can talk about the leftover pieces because, of course,